is my audio right now?
Yep.
I'm sorry. I'm still waiting.
Did it not pick up anything?
It's on the. It's in the I'm waiting to get accepted.
Yeah.
Okay, people.
Yep.
Wait. Sorry, I think you have to be.
The YouTube students.
Okay, cool. Can we make co-host? Yes. So much power. Amazing.
Okay. And then if you guys want to check, Dawn, can you check that video quality is fine, and then we'll start letting people in.
Yeah, video quality.
Okay, and then audio quality works.
Yes.
Okay, cool. And it's pinned on Abby. And Abby, if you start screen sharing, does it register on the back?
Oh yeah, let me try. Oh my gosh, my computer's bugging out. Wait, I'm okay. I am trying to be healthy.
I'll take.
All right, I'm gonna share my whole screen. All right, do you see?
Oh, it works.
Good?
Okay, yeah. Okay, it's lit. It's on currently on Zoom screen, but yeah. It's fine.
Okay, yeah.
We'll start letting people in.
Okay.
Oh yeah, and also are we like let me turn on the what HDMI cable are you plugged into?
I'm not plugged into anything currently. Tony, you need a plug. Oh, would you need an adapter?
I brought one.
Oh, thank goodness. I have a dongle as well.
Oh, no, nice.
Okay.
I don't like my dongle.
I'm not having an HDMI port.
The new Max had it. It's just that this is 2020.
Sorry, I'll
It's 2020.
Okay, I just want to check.
You're first, I think.
Here's the dongle.
All right.
Anchor more truck.
Anchor what? Oh, Anchor. All right.
Does that work?
So look.
We're going to see. Oh, yeah.
It's working.
Is it working?
Yeah.
Great work, team. Okay.
Yay. Amazing. Oh, there's another one?
Yeah, there are two. You can have two.
Okay.
You guys get double the fun.
Okay.
Maybe. Wait, is everyone in the Zoom? Okay, amazing.
Okay, if you stand here right between them, then you should be caught on the same stage.
Yes.
Yep,
And
yep.
then it's also sharing to the same.
Yep.
Are you scared? Oh yeah, you need a screen share.
Yeah, you guys can.
Wait, actually, can we get just one?
Yeah.
Here, I'll. You guys want to come in as well?
Yep.
Yeah.
It's gonna be a. Take care.
Oh, so many people! Oh my gosh, that's so exciting! Hi, you guys. Forget how to work this. Yeah, but it'll have to come like in the middle. Like,
Sorry, what is this?
Like, it's officially slated to be until 9. It's the building.
Yeah, the brokers coming quite soon, but also we highly recommend, like, I think there's a lot of value to share. So honestly, if, yeah, like.
Can we also just get one? Because I'm gonna do some more work for freshmen. Wait, why? Oh, where if I leave 1 hour? Your face is on your screen.
My face is on.
Yeah. Your face is here, there, and here. Because when you got 6 copies, you got 4 hours.
There's a lot of seniors here.
Oh, in other
Why-
majors or like,
No,
yes.
pretty sure.
I hope it is high.
Oh, it's still projecting. All right. Should we roll?
Alright. Yeah, let's try it out.
Abby, is it chill if you just do a little Dolly concert?
Wait, yeah, that's fine.
Is it bad? No. It's like she wants to. Sorry. Oh,
Wait, it's chill, it's chill. Well, that's not, but this being on is fine.
Give us that. Thank you. Sorry, you guys are the. Oh no,
Wait, it's okay, it's okay. All right, I guess we'll get started then, since it is time to start. Okay, welcome everyone to Start Hacking Workshop. Tony and I are from MIT Weblab, which if you have not heard about it, it's basically an IAP course where you get to learn how to code a website in a lot more detail than we're going to go into in this 3 hours over the course of 2 weeks. And then you're in teams and you get to actually code a website for our competition in the last 2 weeks. It's a ton of fun. Y'all should pull up. If you like what you see here, it's like that, but more. All right, that's my obligatory Weblab hub. I'm Abby.
I'm Tony.
All right, so the basic rundown of how this is going to go today. Can I have everyone's attention, please? Okay, cool. Is first we're gonna go over Git and how to use your terminal. Basically, just like the most basic way to collaborate with other people using Git and GitHub. Then after that, we're going to go over basic fundamentals of HTML and CSS. After that, we'll go into React, which is a more advanced way of building your front end, what you see on the website. And then after that, we'll go into Flask, which is how you build the logic, the main part of your website. Just to get a gauge for where you guys are at, raise your hand if you have like significant programming experience, like a major or minor or something, computer science. Yeah, okay, I see some like very hesitant hands. All right, raise your hand if you would say you have like barely programmed before. Okay, we got a few, great. Okay, raise your hand if you've seen Git before. Okay, most people, so this will not be new. Raise your hand if you have done HTML or CSS before. Also a good number, but not everyone. Okay, React. Okay, and Flask. Okay, got it. So it sounds like most of y'all are here for the web dev part rather than the programming part. Cool. Are we giving out, Dom, are we giving out boba now? Okay, sounds good. So true. All right, let's get rolling.
Okay, so this workshop is for designing. It's designed for people who can come in with almost no programming experience at all, like don't even know how to touch your terminal. And we want to get people from there to being able to write and create their first web application. So the first thing we're going to go over is something called Git, which is used for version control. So what exactly is Git? Well, the central question we're trying to answer right now is how do we collaborate on our code? Because hopefully you're just not writing on a Google Doc and copying and pasting to each other. So let's take the following example where me and the friend are working on some document together or some code together. Let's say that he's working on the homepage of the website and I'm working on something that the homepage needs. All of a sudden, one day I decide to put the feature on maintenance. So he'd be like, dude, what happened? I'm working on the homepage and I need your feature. And I'll be like, I'm upgrading the feature. You have to deal with it on your own. So he's like, can you not work on the feature while I'm doing it? And he's like, you have to deal with it because I have to get my work done. So ultimately, we see that we need, in some sense, independent copies of the code so that people can work without disrupting one another. But having independent copies can create a lot more problems. For example, let's say that I have a bunch of my own code changes and he has a bunch of his own code changes. And we're trying to do this weird like copy paste system where we try to communicate in a giant group chat and say, hey, can you change this? Can you change that? But let's say that we do a bunch of copy and pasting and sometime in the future, I actually needed some lines of code that I deleted a few hours ago. Then we have to roll back and desperately try to find what code we missed or changed or deleted. But let's say hypothetically, you and your best friend are super besties at copy pasting and working together on a Google Doc. Well, let's say that someone else joins your project. They're not a part of this huge group chat of Python that you guys are writing. And there also is a question of whose code is right and the most up to date. So here are all the problems that we're addressing. We need independent copies of the code base. We need to be able to merge people's copies together. We need to keep track of versioning to make sure that we can go back easily and see what we have changed in the past and what is new. And we need to make sure we know which version is the most up to date or not. Everyone following why we need some type of system for this? Okay, so we introduced Git. What exactly does it do? It tracks changes by using something called math. Essentially, when you have different versions, version 1, version 2, Git changes the little red part, it tracks it so that it remembers what changes between your code versions. So let's say I write something like, I like corgis, and I delete something about cats. Then Git is going to remember that on line 4, it's going to add I like corgis, and on line 3, it's going to delete something about cats. So just to set up a working example, I want to demonstrate some terminal fluency. Can you raise your hand if you're not comfortable with the terminal? So I know, okay, at least there's one person. So your terminal is built on your operating system where we can navigate our files. And the most simple commands we have right now are ls and cd. So if you can just take 10 seconds to open up your terminal. Just real quick. It's a very simple example if you want to follow along. Yeah, so this is just going to be a simple thing to get people comfortable with the terminal. So let's say that when you open a terminal, you're in some type of directory or folder containing more folders or files within your computer. To list everything within the folder, you type ls, and it should list all of your folders for you. If you type cd, it stands for change directory. So you're also able to pick one of these folders to move into it or out of it. I used to do something like cd ... which goes back to the parent folder or the folder that is containing my current folder. Let's say that I want to make a new folder. I can do make directory and the name of the new folder. Let's say git example. I could go into it using cd. And I see that my terminal is saying that I am now in the git example folder. Now to start using Git in this repository, in this folder, I type something like git init, and it basically creates a Git file that allows me to track changes throughout my code. Any questions on terminal fluency at all? Okay, so we can get started. So the main focus of Git is to be able to create a version history of our code so far. So as we can see on this side, we see that there is a bunch of boxes with labels. So that each one of those boxes are going to be sort of like developer checkpoints. We set like a concrete time step in our code. On the left, I'm going to make a sequence of code changes, such as I like cats, I like corgis, I like huskies. That's one of my friends. I like Andrew. And I'm going to use something called the staging area to prepare for a new a new commit or one of these boxes on the side. So let's say that I'm working on my code and I make a couple of changes. Let's say I work on cats, I work on a dog file. I say that I like huskies, and I say that I like someone named Andrew. And all the while, I have developed a sequence of commits or developer checkpoints over time. And all of a sudden, I think that this is a good time for me to create a new checkpoint in time, create a new commit. So I have my staging area. Now I'm going to name some Git commands to help create this new checkpoint. I do something called git add to take some subset of the changes that I made, and I put it inside the staging area. Once I feel comfortable with everything I have here, I can solidify my changes using git commit, and I add a little commit message to tell me what that package of changes was about. Questions on the overall concept of what we're trying to do? Okay, so now we're going to do an example. So go ahead and take that Git folder that you have, and you feel free to open it up. And I'm going to make a new file. Let's say getx.txt. So any type of text file. Yes. Good question. This might be something you have to set up ahead of time, but I can type code and then the name of the folder that I'm opening up. The folder that I'm opening up, one dot, means I'm opening up the folder that I'm currently in. This might be something you have to set up in Visual Studio Code later separately if it's not there by default. Make sense? Okay. So I'm also going to open a new terminal. I can go to here, create a new terminal. And I can first type git log to see what my log has been so far. I have not made any changes so far, so there is nothing yet. Let's say that I make some code changes. Maybe we can just name a fun fact. The mitochondria is the powerhouse of the cell. And I do Command S to save it. Now, if I do git status, it sees that there are code changes that are made, but not in the staging area. So going back to the slide, there is a sequence of changes that I have made in my computer, but they're not in this cardboard box yet. To put it inside this cardboard box, I do git add, and the name of the file I want to shove in that cardboard box. So git add, git example dot, I misspelled txt, but git add, git example.txt. And if I type git status again,
Can you make it bigger?
If I type git status again, I see what my workspace looks like so far. I see that the git example text file is now in my staging area, or it's green. Now let's say that I'm comfortable with the set of changes I want to solidify in time. Then I can type git commit -m and add a little commit message to specify what exactly I want to indicate what these code changes are about. So I can say something like first commit. Now we have that little set of code changes, and it's shipped up to that sequence of commit histories. So now if I type git log, whoops, wrong one. Now if I type git log, I see that there is my first commit. And there's something special about it too. It shows who wrote it. It shows what time I committed that sequence of changes. And it also has a specific ID associated to it. Now, if I type something like git status again, I see that my workspace is empty. There's nothing that needs to be added to the staging area, and there's nothing in the staging area. That's because all of the changes that I have made, I have already solidified into a commit. Questions so far? Okay. So I want some time to have people try it themselves. Try getting comfortable with add committing and checking the log. And for fun, you can also do git diff and git status to see what your status is so far. So I'll give you guys like 2-3 minutes. 2-3 minutes to try this out on your own. Yeah, please let me know if you have any questions whatsoever.
Yeah, or if you want to go back through anything that we talked about. Oh, heading out. For this? Yeah, that's okay. I'm keeping track. I divided up 3 hours. So I know like if we ever had that risk over. Did it good? Solid explanation. And you've done it before, so I'm not surprised. It's been a little under 2 minutes. Can you give us a thumbs up if you're ready to move on? Thumbs down if you want a little bit more time to play around with it. Thumbs up. I'm seeing some ups and some people refraining to comment, so I think we will move on then. Cool.
Okay, so the next question is, okay. So now that we have a way to keep track of version history, now the big question is, how do we collaborate on code together? Well, that sequence of logs, that log of commits that I told you about, is actually something known as an object graph, where each package of changes we could visualize as a slow circle called a node. And as we saw, it has a commit ID as well as a message about it. And that really shows that there is a sequence in history of how that code was built. Now, we're going to talk about remote branching. So let's say that Abby here has her own sequence of commits, a log that she has, and there is something called GitHub, which hosts that's somewhere elsewhere where that sequence of logs is. And Abby's code and that GitHub's code is identical. Let's say that I want to be able to have a copy of this code for myself, so that I can also see what's going on and maybe I can also work on it. So I do something called git clone, and now I have that exact copy on my computer. Now I could do my git add, like I can make my code changes. I can do git add, and I can put in the staging area, and I do git commit to take all those in the staging area and solidify it into a new commit. And now I see that I am now a little bit ahead of the remote server. Now I can do something called git push to be able to push my code and update our centralized source of information. Now Abby can do something called git pull to be able to look on that remote branch and fetch all the new changes that she doesn't have. So basic workflow for collaborating, pull as much as you can to make sure that you're updated everyone else's code. And as you're working on things, when you're ready to make a new commit and ready to push, just git add, git commit, and git push, and just repeat.
Okay. So basically there's a fancy thing that you could do called branching that will make your process a lot more streamlined. But since this is a 3-hour workshop, we're just going to teach the standard workflow of pulling and pushing. And so this is an example to illustrate why you want to pull as often as you can and talk a lot with your teammates as you're developing your hack app. So let's say both of us, we all have the same copies of the code. We're happy. We're both about to start working. We haven't really talked to each other, but Tony's like, oh, I think it'd be great to have a new API endpoint. We'll talk about what that is later. And meanwhile, I'm looking at the same file and I'm like, oh, that needs some serious cleaning. So we're both working, la-di-da-di-da. And then Tony finishes his code changes and he makes his commit. He does git push, and now the remote server has his changes. He's all happy. Meanwhile, I don't know that Tony was doing anything, so I just keep working. And then I have successfully rearranged everything in the API folder file, the same one that Tony was just working on. And then I want to git push.
Oh no, Abby got cockblocked.
Oh no, what happened? So we get a message that looks like this. If you've ever done software, you've probably seen this many times. It means that there's a commit on remote, and there's a commit that I have, and I don't have the commit that the most recent commit from remote. So it's saying you got to pull in whatever was in remote before you can push anything in. Okay, so I'm like, all right, sure, I'll do git pull. That's what it says to do in the error message. I do git pull.
I got cockblocked again.
Oh no, what happened? Well, it turns out that as Git is taking the changes that Tony made from remote and pulling them into, trying to pull them into my side of things, then it realized that, oh, we both made edits in the same file. It doesn't know which changes it should actually be like taking as truth. So it is confused. And now we're going to demo what a merge conflict looks like and how you would resolve it.
So this is probably going to be very common if you are working in a team. So I want to demonstrate how to resolve a merge conflict, but I'm going to personify our branches because we're not going to have two people working on my computer. So I think my screen. Okay, there you go. Okay. So let's say that I'm going to do, don't worry about this. Let's say that I am Abby, and I'm going to, I feel like I need to make a lot of changes to the mitochondria. Let's say I want to say something like, it is also a really big mitochondria. And it also says something like, Abby is wearing a bucket hat. Sweet, okay. So she does her git add, she does her git commit. Yes.
L. X in the chat.
Doing something. Plug it out. Should take it out for your birthday.
Good try.
Yeah, to go.
Oh,
Okay.
okay. As I was saying, I am Abby. I am making changes to the code file. So I do git add to put everything up, and I do git commit to make a solidified package of changes. Abby is wearing a bucket hat. Great. Then on Tony's side, let's say that he writes something that contradicts whatever Abby did. So I'm going, Abby is wearing a party hat. And I also do my git add, I do my git commit, and I do the commit message. And all of a sudden, I want to merge Abby's changes into mine. So I do something like git merge.
In our example, it would be git pull, but this is a slightly different setup.
Yeah. Now Git is saying that it is confused because you are trying to merge contradictory information. Is Abby wearing a party hat or is Abby wearing a bucket hat? It wants to know which one is true. So as we see, there is a difference between the current change that we are on, which is my changes right now, and Abby's changes, which is changes that I'm trying to pull from. And it says, which one is correct? Abby, what hat are you wearing?
I'm going to wear both hats.
You're going to wear both hats. So we have the choice to accept the current change, the incoming change, or both the changes, or something in between. Let's say Abby's wearing both hats. So I can resolve this merge conflict.
You can also manually edit.
Oh yeah, and you can also manually edit it too. Abby really likes hats. Now I can just make a new commit. And in my log, I see that I have both the previous commits of both made by me and by Abby, and what I did to merge them together. So this is going to be a very common occurrence, especially if you guys are editing the same files as a team. And merge conflict is something that is a very key thing to be able to resolve.
So this is just a graph, or else here. No, that's okay. So this is a graph of what it will look like in abstractified circles, where you have both the changes that Tony made in purple, the ones that I made in green, and then the yellow one, which is the commit from when you merge the two changes together. And then our history has everything. But it's a lot of work. So if you don't want to have to deal with nasty merge conflicts all the time, make sure to pull often. Pull all the time. Before you start working, if a teammate makes a change, if they don't make a change, just pull the check. And every time before you push. And then also make sure you're talking. So try and not edit the same files at the same time. Yeah, that was all that we had for Git. And I think now is a good time to hand out boba. Anyone have any questions on anything we covered so far in Git? Amazing. This. Next session is going to be HTML and CSS.
Will we ever learn about like branches?
No, but we have a WebLab lecture that you can watch online about it if you're curious. I can direct you to that.
Hey, Sam.
Wait, so you guys have like online resources for that?
Yes.
Could you grab me the
Yes. So it is a combination of the WebLab website, weblab.mit.edu, and our YouTube channel. If you search up MIT WebLab, you can find it, and you can find all of the lectures for. Actually, wait, I think the links are also on weblab.mit.edu. So if you go to our last year's schedule, it'll have the links to the videos and the slides from all of our lectures. Of course. Oh yeah, also all of our slides from today are also in the Discord for Hack.
Okay.
Wait, how do I join the hack this?
That is a question for one of the Hack people and not me. Who is?
Sorry.
Someone needs to join the Discord.
Are you? Oh, are you a host?
No.
Or are you a late admission? Or are you? It should, because if you were admitted earlier, you should have received like an
Yeah, what's up?
email alerting.
Oh, wait, I didn't apply. Don't wait for like.
Yeah, so if you want to like join HackWeek, like send
Mobile phone.
Do you have Python version?
be the
Are
host,
you
or
guys,
like
can you guys
come
get
on the day
a facility
and
or how do you want?
Yeah. Okay.
and we have
So instead of using the command Python anytime like we're demoing, you just use Python 3 units.
so
Could you clean it up?
It's like a weird thing with where
Not
Python,
saying
where
also,
your
but-
computer installs Python.
Abby, do you want to size? Abby does not.
We can take a look.
Yeah. Oh, no problem. They're in they should be in the
I can
Slack,
just
Planning on
the
spelling their boba out.
hashtag beginner channel in
Spelling their
Discord.
boba.
Oh,
I
where?
posted the link.
Where's the spell?
Right there.
Oh, that's
Oh.
unfortunate.
Yeah.
Guys,
I can go get paper towels, but like.
No worries.
yeah,
Just so you
no
know.
worries. As long as CAC doesn't care about this.
Okay.
Oh, I guess not. It's okay.
I don't think we were muted. Oh, did someone say we were muted?
No.
No, I was yapping about paper towels.
Oh my gosh! It's Eleanor! Why are you here? You took WebLab. Oh, okay. I thought you were here as like a student, and I was like, you should not be here. This is like a like very condensed version of Weblab in 2 hours, 3 hours.
It's terrible.
Like messages
There's like
increase.
10 emails.
Yeah, like code.
Hack is so stressful. Well, yeah.
No problem. It'd be like that. Okay. Let's see. It's okay as long as we start at 6:50, we're good.
So I can put the.
I would imagine it's fine.
Yeah, yeah.
I see bobas with no owners, which means people have left the room. Okay. We're chill. Yeah.
So I pulled up the slides. I was just wondering where I would find like how to create or like get started on here.
So here, I think earlier in the slides, it should say, where is it? Here. Yes. So this is how you can make a directory, go into it, and turn it into a Git repo. And then after that, the Git status, Git log, etc. All of that will work.
Learning that in the terminal on the computer or in the VS.
These two are exactly the same.
Oh, okay.
So you can do it in either.
Oh, perfect.
Yeah.
Thank you.
Yay.
You just drink it, bro.
Does anyone here have a friend who is not currently in the room who we should wait for? All right, cool. I'm gonna assume that basically everyone who needs to be here is here then, and I will start. All right, amazing. So, we already talked about how to get around on your computer. That's like how you're gonna manage your project as a whole. Now we're gonna start into like actually making your project. So HTML and CSS is the language that controls how you see things on the web. So we're just gonna quickly blaze through the basics of this, and then don't worry if it's like really fast and you don't catch everything, because HTML and CSS you pick up pretty naturally over the course of just doing it and Googling stuff. So don't worry about like getting everything. We just want to expose you to generally how it works. Oh, there's animations. All right. So the basics, HTML stands for Hypertext Markup Language. That's the obligatory what it is. And it sets up the structure of your web page. CSS, oh, never mind. I wasn't talking about that. HTML, in essence, basically breaks down your web page into a bunch of boxes inside of boxes inside of boxes. So for example, we have the website XKCD. There's a big box that's like the entire website. And then there's a box for the content. There's more boxes for these different areas of the website. Even more boxes for the other subparts. More boxes, more boxes, more boxes, more boxes. That's HTML. That's basically all there is to it. So this is an example of how you would make a very simple HTML page. It looks like this. At the top, we have this thing that says doctype HTML, and all that does is it tells your browser to use the most recent version of HTML. It's just kind of syntax. Then basically the way HTML works is that we have an opening tag designated by the brackets and then whatever the tag is, and then the closing tag, which is exactly the same as the opening tag, but with a slash. And generally we use indenting to show what tag corresponds to what. So then we have our opening and closing tag for HTML. That's going to contain all of our HTML code. Oh, yes, that. Okay. Note that when we're nesting tags inside of one another, we cannot do anything like this. HTML won't know what that is. It will be sad. All right, next section is the head section. This head section contains everything that you will not actually see on your website. So it'll contain, for example, what will be displayed on the little tab. If you want to display a little icon here called a favicon, that information will also go in the head section. If you want to link your CSS style sheet, that will also go in the head section. So anything that information that you have correlating to your website that is not actually going to display on the page. Then the body is everything that displays on the page. So for example, the most basic ways of doing text are using headings and paragraphs. So H1 is the biggest heading, and then you can have H2 for smaller than 3, 4, 5, 6. And then P is for the most generic text. So that's an HTML site. So basically, this is in summary, all of the most basic HTML tags that you need to know. We'll talk about div in a second. Does anyone have any questions so far? Cool. All right, this is just a review that you have your opening tag and your closing tag. But one thing that you can do is you can add attributes to your tags. So in your opening tag, you can have an attribute equals and then whatever it's equal to in quotes. And we'll see an example of this in a sec. Oop. So one example of an HTML tag where you're going to want to use an attribute is link, which is A. I don't know why it's A, but it is. So if you want to create a link in HTML, we have the attribute href equals, and then in quotes, whatever we're linking to. And then the content is just whatever text it is. So in this case, it was linked to Weblab would go inside the content. Yeah, so this is an example of how you put a link in your site. Another example of something where you would want to use an attribute is images. So the image tag looks a little something like this. For the source, we'll put the file name of the image that we want to insert. So in this case, if we have a GIF somewhere in the file directory that our HTML file is also in, then we're going to put the file name in there. One important thing to note is that the image tag is not like this. It does not have a closing tag. It's a self-closing tag. So it's just one thing with a slash before the end, because you're not going to have image opening tag and then something inside the image. That doesn't really make sense. So this is what it'll look like. Okay. This is what your file structure, your folder, would look like if you had your HTML like this. For example, you might want to have one big folder for all of your files in your app, and then you have your HTML, which we're writing now, and then you have your GIF file. But that's actually not really good practice. So what we typically do is we make an images directory, another folder inside our big folder, and put all of our images in there. So our big folder doesn't get all cluttered up. So then our new HTML self-closing tag would look like that. Cool. Any questions so far? Amazing. All right. Next up, the most important tag in HTML that is basically like the entirety of HTML, I feel like, divs. What is a div? Well, to be honest, it's kind of nothing. So if we have our basic HTML page that we just saw before, and we want to put a div around everything in the body, so around the heading and the paragraph both, what that does is it creates an invisible box around both the heading and the paragraph. It does nothing. The website looks the same. But we will see later why divs are important in order to help us style things and arrange things on our website more nicely. Okay, you're probably thinking here, oh wow, we've introduced a lot of tags, and we have. There are a lot more. Generally, you learn HTML by Googling things. The #1 recommended resource is MDN Web Docs. That's like the most reliable. So if you're looking up, how do I do this in HTML? If you see like your Google might look like W3 schools, MDN Web Docs, some random blog, ChatGPT or whatever, MDN Web Docs is probably your best bet. The other ones are okay too, except W3 schools. All right, so we just talked about HTML. Next, we're going on to CSS, which stands for Cascading Style Sheets. And it basically just makes it look pretty. Basically, CSS is different than HTML because HTML, we just pile in an HTML file everything we want to go on the page. But CSS is going to connect to that HTML and tell us how we want those HTML things to look. Why does this matter? Well, if we have just HTML, we can make a Bon Appetit site that looks like this. But if we have CSS, it can look like an actual website. In other words, you can sort of imagine HTML being the skeleton and CSS making it look nice. There's another thing about it. Okay, so this is a basic example of what part of your CSS file might look like. You start off with a selector. This is saying, okay, anything in your HTML file that's a div, apply all of these styles to it. So all of the styles will be in property value pairs. So all of these properties that you can set, you can Google them. There's a lot of different things you can style. So you have your property and your value. And then now, if we have, oh, okay, this is our new example. Then if we have two divs, then anything that's, okay, if we have our style.css like this, then anything that's a div will have all of these styles associated with it. So then both of those things become red. Another thing we can do, if we don't want to affect all of our divs, but just like one in particular, or a few in particular, we can have something called a class. We can give any HTML element a class, and we can name it whatever we want. For example, if we want our class to be called info for whatever styling we want to associate with info, then we'll put that in our HTML. And for our CSS selector, we're going to do dot and then whatever we want to name our class. So the dot just indicates that it's a class. And now, since this styling is associated with the info class, and only this div has that class, then only this is going to be highlighted in red. Cool. And then one more thing to note. Yes, what's up? Basically, P for paragraph and H and all of those ones have certain default styling associated with them, whereas div doesn't. So div will literally do nothing, but then P might like, or I don't know about P specifically, but like definitely like the H ones, some ones have like default like, oh, it's sized this way and it has this much margin and like that kind of thing. Okay, so one last thing to combine our HTML and CSS together that I did not mention before is that in the head section of our HTML file, we just have to add something like this that says rel equals style sheet. That just means we have CSS, and then href, and then the file path to wherever our CSS file is. That way HTML knows what kind of what CSS file is connected to it. Cool, and then we can style accordingly. All right, so let's try this. I am going to code up some basic HTML. If you want to follow along, feel free. If you want to just watch me, also feel free, whatever you're feeling. I'm just going to make a super basic website. Hide floating data controls. All right, so here's my folder with this ginormous name that I'm going to use for my HTML site. Can I never mind, that doesn't work. All right, so I'm going to make my new file called index.html. That's generally what you call like your main HTML page. And then I'm going to do all the stuff that I'm supposed to do. Doc type, HTML, HTML. And then generally it's good practice to like put your opening and closing tags together, like put them down at the same time. and then go in and indent. So you make sure you always have opening and closing tags. You don't want to lose those, then you'd be really sad. All right, so we have our head section. We are going to put in whatever title we want. So I'll put in Abby's Cats website. And then we can put in whatever the link to our CSS file, which in this case I haven't made yet. So I'll just leave that as is, we'll change it later. Then we have our body section, which has all of our stuff. So for the sake of example, I'm gonna put an H1 that also says Abby's Cats. And then I'll have a paragraph that says, my name is Abby and I like cats. All right, and then I'll also put in an image. So we'll do image source equals images slash cats.gif. And then we can also put alt text, which means if you roll over it, then it'll say what it is. So I'll say cats. Ah. Okay, and since this is a self-closing tag, we do slash and then our closing brace. And inside the images folder, I just preloaded this because I don't want you guys to wait for me to go search up things on Google Images. But here's my GIF. All right, so how are we gonna run this? Well, all we need to do is we just open up our web browser and then take our index.html and drag it into our web browser. Oops, that's not what I wanted to do. I need to open it up in File Explorer. My bad. Boop, 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 boop. All right, so I take my index.html file, I drag it into my web browser, and then Google Docs. All right. And then it will open up the file. And there is my little website. Amazing. All right. So what I am going to do next is I'm going to add a nav bar at the top. Now, I'm not going to have multiple pages, which you would do with a nav bar, but like every website has a nav bar, so I want to have a nav bar. So what I'm going to do is I'm going to type nav. This could be a div, but it's kind of conventional to use nav. And then inside it, I'm just going to put Abby Cat website or whatever I want to put. I'll just have some text. Now, let's start adding some styling to this website. So I'm going to, I think I will create a folder for this. So I'll create a folder called styles. And then inside it, I'll put a file that's called styles.css. Cool. And then here, I'm going to make sure that my file path in the head section of my HTML is named accordingly. All right, so I have my styles.css. What I'm going to do now is, come on. Oh, there we go. Is I'm going to style some of these things. First thing is I'm going to style my nav bar. So I'm going to say background color. And then let me just use an HTML color picker to choose a color that I think is pretty. I'm going to make mine purple. And then this will give me a hex value that represents the color that I like. I'm just going to copy that and stick it in my CSS file. Another thing that I can do to make my website look more customized is I can go to Google Fonts and find a font that I like. So basically, all I need to do is find something that looks nice. Let's go with this. Click. Oh, I already added the, you know what? Click Get Font. And then I will get the code that I need to embed my font into my website. So it says the embed code. I can use @import here. And I'm just going to take that and copy that line into my CSS file. And so that imports the font for me. And now what I can do is I can just do font or font family is Comforta. And then sans serif is just like the backup font that it'll use if it can't find this one. And now, hopefully, if I did all of that correctly, then if I reload this, Yay, it worked. So now my nav bar has the background color that I want, and it's the font that I want. Cool. This looks great, but not great. Specifically, I'm going to focus on my nav bar. Can anyone tell me like what would make this nav bar look nicer? Or sections. Yes, that is true. But I am not going to add those today for the sake of time. Anything else? Yes. Yeah, making it a little bit wider or like taller. Anything else? Yeah, okay, we can add a border. So one thing that I don't like in particular that you were kind of getting at is that the text is this big and the like, this stuff is like exactly that big. That looks kind of gross. I kind of want a little bit of space between the size of the nav bar and my text. And so in HTML, that's something called padding. So basically how HTML works is, this is known as the box model, but I'll show you inside our developer tool. So if I right click and go to inspect, I can basically see everything on my site and sort of interact with it. So what I can do here is I'll highlight the body, and notice that it highlights whatever my mouse is currently rolling over. I'm gonna go into my body, look for my nav bar. I see my nav bar here. Now over here, we have something that represents the HTML box model. What this is basically in HTML, there's a bunch of different things that define sort of the size of your content. There's the size of your content itself, which in this case is just my text. So this is the height, the width and height of my content itself. And then there's something called padding, which we'll show you in a sec. And then there's the border, and then there's margin. So basically, if I have content like here, then there's going to be some, we want there to be some space between my text and whatever else is going on. So that's padding. And then if we want there to be a visible border around our nav bar, then that's going to be our border. And then there's also going to be some space outside of the border that stands between this stuff and like anything else that I have on my website. So then there's going to be margin as well. So what that's going to look like, first thing, we're going to add some padding to my nav bar, and I'll show you what that looks like. So we're going to go into our CSS, and then, oh, the people on Zoom want to see the board? Yeah, can they see it? Okay, we'll show you online anyway, so it's not a big deal if you don't see the board. All right, for our nav bar, we're going to add padding, and then let's add 16 pixels of padding. That'll add a decent bit. Refresh the page. Oh, look, there's more space now. Yay, amazing. And then you can see also in my expect element here, the content is exactly the same size as it was before, but then padding is 16 pixels. Still no border, still no margin. Another thing we can do with our padding, if we want it to be like 16 pixels on the side, but like shorter on the top, is we can do 16 pixels, 8 pixels, and that'll like make the size to be 16 and the top to be 8. Or it might be the other way around, to be honest, I kind of forget. Nope, it's the other way around. As you can tell, you can kind of just play around with it and Google it. I don't memorize anything in HTML. Cool, so that's padding. The other thing that I kind of don't like about the way this website is set up is that there's this awkward white space here on the top and on the side. I kind of want my nav bar to just fill up the whole top of the page. Now, like, does anyone have an idea of why that white space is there? If not, that is okay. Cool. No, and it's kind of befuddling at first, but inspect element will help us figure this out. Basically, let's just click around and see. Okay, I see the body. It has this blue box and then some orange border around it. So let's click on that. And if I select the body element and then I go over here, I can see that the content of the body is a certain size. There's no padding, no border, but then there's an 8 pixel margin around the body. And that's just something that HTML does for us by default. Let's say I don't like that. I want to remove it. So I'll go back into my styles folder and I'm going to edit the whole body of our thing. And I'm just going to say margin is 0. And if I go back, oh, look, it's gone. That's amazing. I kind of don't like how this is up against the wall now, but I'm going to ignore that for the sake of demonstration. All right, so this is my site. Next up, though, we just talked about how we can put stuff into our HTML file and it shows up one thing after another, everything below each other. But like, I kind of want to arrange my site a little more nicely. How do we put things next to each other? Like this, going from this on the left to this on the right. Well, if you Google and go to W3 schools, they will tell you to do something like this, using float left or like float right, like that kind of property. That's wrong. That will make you sad. It will give you a lot of bugs. The right way of doing it is using CSS Flexbox, which is something that we will introduce right now. Basically, it's a super powerful way of controlling exactly how your divs or your containers in HTML are arranged. So, for example, you can have a div. So here we have a div that's around 3 different divs, which each have items in it. And if we style this div that's around everything, this big container div, then we can change the flex direction from row to column, and then it'll arrange them differently. Just like that. Yay. Okay. I'm gonna continue my example here. How much time do I have? Yeah, we're good. Okay. All right. So in my example, I'm going to add a little bit more to my website. I'm going to add 2 more little sections below. I'm going to add an H2 for my cats. That's a little bit smaller than an H1. And then I am going to, inside my cats, do not what GitHub Copilot is suggesting. And let's put in an image. Source images/peach.png. So that's one of my cats is Peach. Self-closing tag. And then I'm going to write about her. My cat, Peach, really likes matcha. Okay, and then I'm going to put my other cat. And I'm going to write about him. All right, let's make sure that that looks the way that I want it to. Okay, looks about right. Now I want to put these 2 next to each other. So I have, yes, thank you. I'm glad that you appreciate my cat pictures. We want to put Peach on one side and Goma on the other side, right next to each other. So how do we do that? Well, in the example that we just saw, we need to have a div around everything that we want to arrange so that we can style it. And then we also kind of want to have a div around each individual thing. So I'm going to do that right now. So inside my cats, I'm going to create a div, and I'm going to get out of here. Put everything, all both cat guys inside of it. Oh, there's something wrong?
One of Mithu will be eating your food.
Is something, can you not see my code? What's going on?
Okay, thank you.
Oh, okay. Cool. All right, I have a div there, and then I'm gonna put another div around my Peach thing. And then I'm gonna put another div around my Goma thing. All right, and then let's make classes for each of these divs. So for my main div, I'm gonna call it cat container, or cats plural container. And then I'll make another class for Peach container and another class for Goma container. Yay. All right. So if I go into my styling, let's make both all of these classes. So we have cats container, and then we have peach container. I'm not going to put anything in that yet. Then we have Goma container. Cool. Inside our cat container, the first step, we're going to make it flex blocks. We're going to say display flex. And then we're going to say flex direction row, because we want them to be next to each other. Let's see what this does. Go here, reload. Oh my gosh, it worked. Kind of. The weird thing here is that these two are next to each other, but they're all the way on the left. I kind of want it to like spread out when I expand the window to be bigger. So what I'm going to do is I'm going to use something called, wait, I'll go back to my slideshow. Flex basis, which will define the default size of our divs. So basically for our smaller, like little container divs, we can set whatever size would be our default. So let's say here that I want to set both of these things to be default, take 50% of the page, because I want them to each just fill half the page. Let's try that. Cool. Ew, I don't like these floating meeting controls. Let's try. Yay, it worked. It's kind of filling the rest of the page. All right. Another thing we can do is inside of our peach container, I want to center my peach thing. Center my little dude. No, that's so sad. I need to make that a flex box. Can I do that? Yes. No. Okay. You know what? I need to make another div for this, but for the sake of time, I am not going to. Basically, if I wanted to make this look a lot nicer, I would probably make these two the same size and then make it so that both of these, like the image and the text, is both centered within the little subcontainer. And then, yeah, and then it would look a little nicer. For the sake of time, I will not, but both of those, how to do all of that is pretty straightforward, and you can find it on our resource here, CSS Tricks, a guide to Flexbox. And this will tell you how to do just about everything you need to do in Flexbox. And then also just like Googling and ChatGPT and all of that. So yeah, that was everything for HTML and CSS. We're gonna give you guys, let's see. You know what? Do you guys want to take a little bit of time to try it out, or do you guys want to just move along to React? What are you feeling? Like, one, if you want to take a few minutes and try it out yourself. Two, if you want to just move along. All right, I'm getting more twos, so I think we will move along.
Yeah, don't worry if you want to try this, because you will get to try all this in React again.
Yes, and while you're hacking, like you'll get more than enough HTML and CSS. All right, you can take a 2-minute stretch break while I switch this stuff over to Tiny's computer. Oh, thank you for coming. Y'all ready to move on to the next thing? Amazing. Okay. Hey, you have the mic. Oh, never mind. I can do this. Oops, I forgot. Sorry, y'all, if you get more of my voice. All right, so we roll. So we just learned HTML, which is kind of like the bones of our website. CSS, which is kind of like the skin and like clothing that makes it look nice. And we did not learn this because it's not that important to our purposes, but JavaScript is also part of the code of a website, and that's what allows you to interact with it. It'll allow you to change the content of the page based on a button you click or something like that. So let's say we just coded a website that has like free cat images and some text. But let's say we want to code something fancier. Let's say we want to recreate Facebook. Now, leaving aside the like logging in and like the fact that your feed looks different based on like what you click and all of that, let's just say we have the homepage of Facebook and we want to recreate just exactly what that looks like. Let's put that into HTML and CSS, or just HTML to start. So we would probably start with putting the friend section on the side, so we have a div for that, and then we're gonna put down every single person's picture and their name. Okay, a lot of work, but we got it. Then we want to add HTML for every single post. So in the post, we have the little header area, the content of the post, the comment section, each individual comment, a good amount of HTML for a post. And then we look down at the next post and we realize that it looks kind of similar to the post above it. So we're like, okay, I guess I'll just take the HTML from the first post and copy and paste it right below it, and then change up the text inside of it, and that'll be our next post. Cool. Scrolling a little bit more, realize there's another post that looks pretty similar after that. Copy and paste again. And after an hour of copying and pasting, you look at your 3,000 lines of HTML, realize that you made the text, the like button wrong. You need to change every single one, and you're wondering if maybe your work in life really is just relegated to sorting through 10 gazillion lines of nonsense. You're kind of sad. Enter, yeah, you're pretty sad. What if I told you could write it like this, with one line of HTML? Whoa, what does that mean? Well, it's not actually one line, but what's inside of that one line is that one tag. So let's say, okay, sorry, I'm backing up one step. Basically, in our index.html file, or like our main website file, we have one tag that's Facebook. All right, somewhere else, we have facebook.javascript that defines what does that Facebook tag actually mean. Well, it has a navbar, it has a friend section, it has a feed section. And then we have JavaScript files that'll define for us what each of those things mean. So the navbar.js section is going to have all of the little links, then the friend section, feed section, etc. What this is React. Specifically, those are React components. So the idea behind React is that we take our website and we divide it up into little sections, and each of those sections is a component. And then we just build up our website out of these little, almost like customizable building blocks. So what is a component? It's basically something that looks like an HTML tag, but it's actually custom made by you. And it's basically like the HTML tag is sort of an abstraction, or like a wrapper around a bunch of HTML, CSS, and JavaScript that defines everything that this little one section of your website is going to do. So that's a little abstract, so let's just show you what it is. If we have an app that's all of Facebook, then that app component is going to have some subcomponents: the nav bar, the info sidebar, and the feed. Then those subcomponents are going to have more subcomponents. So the feed is going to have several post components in it. And then each post component is going to have the post body and the comment section and a comment. Another way of thinking about this is like a tree, where we have the app as our main component, and then the subcomponents that make up it are sort of like children in the tree below it. Everyone good so far? Questions? All right, cool. Okay, we just talked about that. So let's start coding some React. Let's get into an example.
Okay, so cool thing is that the creators of React made a very easy way for us to start a React site. So go to wherever you want to create the directory. Feel free to follow along, but I recommend if you do, if you want to get your hands a little dirty. Let's say that I want to make a new project called, I don't know, React app. First, I want to make that directory and change it into that directory. Now that I'm in here, I'm going to type in this command, npx create React app front end -- template TypeScript. So what this does is it creates something called a React app, which is a set of folders that defines what a React app does and makes. And I create that folder and I name it front end. The -- template basically means that we will be coding in TypeScript. Why TypeScript? Because it's better than JavaScript. So I'm going to hit enter. And it's all basically it's going to construct most of the things that I want for me. So it's going to take just a little bit.
Why don't you pull up this next slide so that they can also what? Yes, if you did our setup instructions, if you follow the setup instructions and have installed Node, then you should be able to follow along. And if not, no worries, you can just watch us or you can find someone else to look on with.
So I'm finished running by now. So I'm going to open my, does anyone need more time setting this up? By any chance? Good, okay. I can open this in Visual Studio Code and we see that we have the front end. I can open a new terminal and I could go into the front end directory and I could do something called npm start. What this does is it basically starts a development server where it basically takes this React app and put it onto a mini website onto your computer. Now, I'm going to basically use an example of coding a very, very broken down version of Netflix called Catflix, because everything is cat themed today. So I'm first going to delete everything inside this app directory, and I'm going to just create a heading, welcome to Catflix. Now with it, also I want to go into the CSS and delete everything. Yes. Oh, you do npm start. Let me zoom in a little bit for that for you. Okay. So let's say that now I want to display a whole set of movies onto Catflix, but I would want to encapsulate it into a component so that I don't have to rewrite the same exact HTML over and over and over again. So a good way to start off is creating a components folder.
Oh shoot, are you screen sharing?
I am not.
Ooh. Am I sure?
I got it.
Okay.
Yeah. So the first thing I'm going to do is create a components folder just so that I make sure I'm a little bit more organized. And within this components folder, I'm going to make a new file known as movie.tsx. sometimes when you create new things, you have to rerun the npm start. Okay, it's not working. It'll work later, hopefully. Yeah, it should work later. So we're going to create our first React app. So we're going to import React, and we're going to define our React component. Are people familiar with arrow function notation? Raise your hand if you are not familiar with arrow function notation. Okay, so a very common thing in JavaScript and TypeScript to do is something called arrow function notation, where typically to create a function, what we do is we say something like function, and then the name of the function, and then you specify the parameters, and then you specify the output, and you write something within the body of the function to specify what to return. So I hope this looks kind of familiar. So this is a very simple function to add two numbers, a and b. In arrow function notation, what you do is you declare a variable using const, and you say the name of the function, which is add, and you set it equal to, and you put in parentheses, the parameters of the function, and then you specify the output. Then you use a little arrow to annotate what exactly that function is going to do. So it's something like return a and b. So these two are equivalent in nature. So we have the function name here. We have a set of parameters we're using for the function, and we have that output of the function. Question so far? Now there are some shortcuts that we can do in arrow function notation that we are not able to do with ordinary function. For example, instead of brackets, I could put this in parentheses, and I could just delete the return statement. That still returns a plus b. Even simpler, I can also delete the parentheses. That also still returns a plus b. So using arrow functions is a very clean way to represent functions.
Yeah, it's basically just like in the parentheses, you put in your input, whatever the function is taking in, and then you have your little arrow, and then it's whatever the function is outputting. So Tony, what is the function in a React component? What are we inputting and outputting?
So currently we're inputting absolutely nothing, but it's saying that this function is of type react.fc, which just means functional component. It's telling TypeScript that this is a component in React. What it's outputting here, which is interesting, is that everything you type above this return statement is going to be ordinary JavaScript. But everything here is going to be something known as JSX, which is a mix between JavaScript and HTML, which is pretty interesting. So everything here in the return statement is the things that are rendered in a React component, the things that are seen in your website. Everything before that is going to be all the logic that you're going to do. We're going to see how this logic works in state and props later. So let's say that this is a movie component, and let's say that the movie has a name, such as like Cat Vengers, and it has some rating to it. Let's say it's like 5 out of 5. At the end of our React comment, we want to export the movie component so we are able to use it later on. Everyone?
A lot of this syntax is a little wonky. You can feel free to just write it down for now and then come and ask us later what everything means.
Okay, now that I have finished my movie components, I can go into my app.css and I could import it from within the components folder, get the movie TSX, get the movie.tsx component associated with it. Now let's say that I want to load a bunch of movies into Catflix. Then I could just say movie with a self-closing tag.
You haven't closed the tag, bro.
Movie with the self-closing tag. And I'll say something like Cat Vengers. And I can now duplicate that many times.
Oh my goodness.
And I'll have a bunch of Cat Vengers. Obviously, this is a little bit ugly, so we're going to use the flexbox trick that Javi talked about. So we're going to put all of these movies inside a div. And let's say that I'm going to just give it the class name container. Note that in React, instead of saying class, you say class name. And then I'm going to specify a container class. Let's say that I want to add more to the individual movies itself. I could create its own CSS to separate things out a little and organize things better. So I could do movies.css. And then from movies.tsx, I could import movie.css. Movie./movie./movie. So let's say that this is a single movie component. And in the CSS, I want to be able to edit it a little bit. So I do .movie to specify what type of elements that I'm targeting. So just to make it a little prettier, I'm going to add a little border. And maybe I'll fix the width of it to be like maybe 20% of whatever's there. Now let's see what it looks like. Now they're actually little boxes.
Yeah.
I could also text align the center to make it a tiny bit prettier. But they're all still stacked on top of each other. So what we're going to do is we're going to use. Are we following so far? Did I lose anyone? Okay. So what we're going to do is we're going to go inside app. We notice that we have a container class. So within app.css, we're going to tell the container class to be a flex box. So we're going to say display flex, and then we're going to say, what was the wrap?
Flex wrap.
Flex wrap.
Yeah.
And now things are going to wrap around a little bit more nicely.
Wow, so cute.
We can also play around with justifying the content. So wanting things in the center, having space be between it, have space be as far as away from each other as possible. What is the space around? Evenly space it completely.
Or you could do justify.
Yeah, you can also do justify. Can you do justify? Yeah, or you can just do the normal one.
Oh well.
Yeah, I can add a little bit of margin to each side to make sure that they're a little bit spaced out at least. I can add a little bit of padding to make sure that it's a little bit prettier and not close to the border. But yeah, now we have a bunch of movie components in CapFlix. So I'm going to pause here for a do-it-yourself. So I want to, between Welcome to CapFlix and a bunch of movies, I want to display a bunch of accounts. So feel free to start making a account.tsx component and displaying a bunch of accounts the same exact way, and see if you can get the flexbox to be played around with.
Also, let's just take this moment to like pause because that was a lot of code. Does anyone want us to go back and go through any files, anything that you wanted to copy down but missed, any concepts you wanted to go over? Yeah, what's up? Okay, just like an overview of, yeah. Okay.
Yeah, so app.tsx is where is my biggest starting point in React. So everything goes inside app.tsx. But let's say that I want to create components to be reusable. This is a little bit of a stylistic preference, but I put all my components inside a components folder. Within the components folder, I have a TSX file to specify the React component And I have a CSS file to specify what everything in there should look like. Within the TSX file, I have my, everything here is unnecessary. I have my actual React components where it's actually a function that takes in no input and it outputs a bunch of HTML. So I could do a bunch of logic within the functional component, but what exactly is rendered to the screen is everything within the return statement.
Cool. Does that answer your question? Okay, cool. Anyone else want to go over anything again? Cool. Has everyone, raise your hand if you've been following on your own computer? Following along. Okay, so most people are just watching. Okay. No problem. I just wanted to get a sense.
Oh, okay.
Oh, yes, there is, in fact. Is the screen share frozen? Wait, that was from like 7:16. I think it's fine. Oh, like you don't have to give them time to work on it themselves. A lot of them are, most of them are just watching it.
But that's basically that.
Okay, that's all. Then are you handing it back to me?
Yeah, because the next is props, right?
Yeah.
Okay.
All right, cool. Can you go back to the slides? All right, so earlier, can you, yeah. Okay, so now we have a component, that's great, but this doesn't really answer the question that I was initially posing, because earlier I was like, oh, if we cook Facebook, we're gonna have to like take all the HTML for a post and copy and paste it 10 gazillion different times and just change each one slightly. Here in the React components as is, if everything is hard coded, then like we're still gonna have to do the same thing. We haven't really fixed anything yet, but we are about to do that now. So the basic idea is that in a component, you remember earlier how Tony just copied and pasted movie components and it just showed up a bunch of different movies on the screen? Well, the basic idea is that like that is almost everything there is the same except for like the title and the rating of the movie. So we want to generalize it. So in the Facebook example, we want to generalize a comment. So what is different from one comment to another? Can I get y'all to like call out what we need to be able to change between different comments? Yeah. Yeah, the content of the comment. That's one thing. What else? There's not very many of you in this room, so like there's really no shame if you just shout out. The name, the profile picture. Yeah, exactly. Y'all got it. That's it. So a general comment has just a general content, author name, date posted, profile picture. Okay, how do we actually implement this in React? Oh, yeah. Something called props. Props are almost like parameters to a function. Actually, in React, we do write them as parameters to a function, where the child component takes in some kind of input from the parent component. So for example, in the Facebook example, the comment would be a child of the post component, because the post has several comments under it. So then the parent, the post component, the parent, will pass down props or information into each of its child components, the comments. And then each one will be rendered by React. So in this case, the post would pass down the author name, content, date, post, profile picture, etc. And then it will render. Two things to note about props is that they are immutable and they can only be passed down from parent to child. Cool. So that's the basic idea around props. And now Tony's going to modify our cat flicks to actually use them.
Okay, so let me check what the info is. Okay. So the biggest advantage of using React is that you're able to control and keep logic and pass it down to a bunch of reusable components. So what we're first going to do is import another thing. Import use states from React. And this is going to oh, we're just hard coding the props. Okay, never mind. I guess we're just hard coding the props. So let's say that I want to take in a specific set of values for my movie component. I'm first going to create an interface which specifies what is the structure for what I want to pass in. I want to specify a title, that is a string, and I want to specify a rating, which is, for now, I'm also going to say a string, just to make it easy for myself. Now I can change this React component to specify I am taking movie props as inputs. Specifically, I'm taking in a title and a rating. Now, instead of displaying Cat Ventures and rating 5 out of 5 directly, I can replace this with bracket title and bracket rating. So what bracket does is it converts this JSX and escapes it, and it's telling you I am writing directly in JavaScript. And inside this bracket, everything will be JavaScript. Title is just a string. This is just a JavaScript string. Now, instead of saying movie a bunch of times, I can specify title is equal to Cat Vengers and rating is equal to 10 out of 10. Now, if we look at the React app, that's exactly what it says. I could also do multiple of these with different movies. Infinity Cats, Civil Cat War. Maybe Infinity Cats was not as good as the other ones. And now I have a bunch of reusable components with props, which means that I can have the same exact structure repeated over and over with different varying information.
Yay. All right. All right, that's great. So now we have a bunch of reusable movie components. And so within our app component, our main component, we can have a bunch of different movies. That's cool. But we kind of don't want to have to hard code the props in either. Because, for example, in Facebook, obviously there's no code lying around Facebook that says Patrick Root, TFTI, well, et cetera, et cetera, et cetera. These props have to come from somewhere other than our code itself. So how do we store information inside a React component? That is something known as state. So state is kind of just information that a React component holds on to, almost like variables in programming. And it can be updated, so you can change it over the lifetime of a React component. And you can change it by human inputs. So like if I click a button, maybe I change a state of how many likes something has. Or if I do a request across the network, which we'll talk about later, to get some information, maybe that'll populate my state. So here, how are we going to store all of the different comments in Facebook? Well, what we're going to do is, don't worry about this complicated looking diagram, but somewhere within our post, we want to be able to store information about all of the comments that are under it. So if we have something in JavaScript where we want to store a bunch of different things that all kind of are similar, then we would normally do that in an array. So we're going to use a JavaScript array that stores all of the comments. What that's going to look like is right here, state, and then here we have this 3-element comments array. And so basically this state is kind of like the JavaScript variable within our post React component. And then that's going to have one of these objects that describes a comment for each comment that we have in our post, like under our post. This is basically, if you're not familiar with JavaScript, it's an object. It's just a bunch of, it's like you take 3 different variables and switch them into one variable. All right, so how does React know how to actually render these comments? Well, what we're going to do is for each one of these comments in the array, we're going to pass all of this information, the author name, comment content, etc., as props into a corresponding comment React component. So it's going to look like that, where we take one of our comments from the state array and then pass that information into a component. As a sidebar, why we keep comment data in post as opposed to in the comment state, it's just because from the post level, it's nice because we can just add a comment and then immediately see the changes, because all of that information is stored in post rather than in comment. All right. So for example, if we have 2 comments under our post and then we type in a comment and add it, then we can just append it to that array. And then what React will do is it'll automatically render a new comment on our page. Cool. And another example of how we can use state is the show replies button. So we can toggle to show a bunch of replies or not. And then this can be just a true or false state that we use. Okay. So as a little quiz thing, where do we want to put the state that determines whether we're looking at all the replies or not? Would we want to, oh, I just gave it away. Whatever, we're just moving along. So basically this is going to be a state because we can toggle it on and off. Would we want to put it inside the reply component or inside the comment component? Give me 1 finger for the reply component, 2 for the comment component. Uncertainty is okay. No one else is looking at how many fingers you have up except me, and I'm not going to judge you, so. Okay, that's okay. Basically, we want to put it inside the comment component because if it's in the reply component, then we're not going to be able to change it at the comment level. So it's going to be like our comment, and then we have a little button like show replies or not. We hit that button, and that's within the comment component. It's about a toddler state inside the comment component. I get the feeling that for some of y'all, the state idea is still a little bit uncertain. So we're just going to do an example so that you can see what it actually is. All right. Basically, state is like a variable you store within your components. And now training will actually show you so that it's a little more clear.
Okay, so first what we're going to do is we're going to introduce state. And this is going to be through the useState function provided through React. Don't worry about the syntax for now, but I'm going to type const movies set movies to useState. And for now, I'm just going to say an empty array. What this does is it creates a variable called movies and sets it to an empty array. And it creates a function that is allowed to change what this array is. Let's say that I just want a bunch of movie data, such as Cat Vengers, Infinity Cats, Civil Cat War, something like that. And let's say that I don't have any movies just yet. Now, I have an empty HTML site, and I just have a bunch of information in my movie state, and nothing's exactly showing to the screen right now. First, I'm going to create a function, create movie component, I'm going to have it take in a movie object. And I'm going to return a movie with the respective title and rating. So it's expecting one of these, and it says I'm going to get the title of it, and I'm going to take the rating of it, and I'm going to return a JSX or like an HTML like object. Now what I can do is in JavaScript, I'm going to say movies.map, create movie component, which takes all of the JavaScript objects containing movies objects, and it takes all of them, and it applies the map. It applies the create movie component function to it, meaning it takes every single one of these and it creates the component out of it. Now, if I refresh the page, I have my components rendered. I'm able to take information from our state and render it into a list of HTML components to be rendered.
Cool. Cool. Do you want me to?
Huh?
Are you passing it to me?
Yeah.
Okay.
I didn't make a toggle.
Huh?
I didn't make a toggle.
Yeah, that's fine. Okay, so the basic idea here, I just wanted to explain a little bit of what the map function is doing here. Basically, all we're doing is we have this information stored in JavaScript where we have the like title of the movie, the rating, etc., all in these JavaScript objects in our React component. That's all in JavaScript. React doesn't know how to render that. We need to change it to HTML, or rather React, so that we can render it on the page. So that's why I need to find this function called create movie component that converts one of these JavaScript objects that has information about a movie to a React looking thing that is the movie component with the prop of whatever title was here. So then this would be a React component that's movie title, infinity cats, and then movie title equals Civil War, etc. Everyone following? Cool. Okay. Amazing. Good stuff. Here we go. And I think that was it for React. Cool. Yes, what's up?
Wait, is the function set movie for anything?
Ah, no, but we would use it if we wanted to change the movies array. So if we wanted to add a movie here, then that's what we would use that function for. Basically, rather than just directly editing this movies array, React doesn't want us to do that because React wants to know when we change something so it can update the re-render, update the page accordingly.
Yeah, so for example, I just added a button that says whenever I click it, it will call a function that calls the set movies function, which basically updates movies. How it updates movies is React state is a little weird, where it copies everything within the original state and adds this extra thing to it. So now whenever I click add movie, it adds it to the state, and React automatically renders it using the map function.
I like that button.
If you want to be able to edit things within the components you create, you can also pass down the functions as props. It's pretty interesting to be able to manipulate things on a high level, but we don't really have time for that.
Yeah. All right. All right. Everyone stand up for 1 minute in case you're sleepy and stretch out a little bit while we, all right, I guess we can just do the last, we're also doing the last video.
Yeah.
All right, yeah. Just tiny stretch break. Thank you all for staying. Y'all are the real ones. No one stood up. That's okay. You guys are all vibing. Yay! Thank you. All right. Also, I like your shirt. It's a very cute dog.
Oh, yeah. I think I had like food on my bed and you're trying to get it, so that's it.
Oh, that's your actual dog.
Yeah.
Wait, that's so great.
Yeah, custom fit.
Oh my gosh, I love that. It looks like a fashion thing, but it's also yeah, like it looks like some like I don't know, like some brand would have like shirts with a dog on it like that. But that's even better that it's your own dog. All right, cool. I guess y'all are ready to roll on. This is the last thing. It's also the most conceptually heavy thing, but once you get the concepts, it will give you like a phenomenal foundation for actually working on this stuff. Something happened?
No.
Okay. All right. So question. What actually happens when we visit a website? Like the word visit makes it sound like we're going somewhere. And like our computer somehow is like going over to some other computer on the website on the internet. No, the internet doesn't work that way. The internet is just a bunch of cables underground that relays messages from one computer to another. So all that a computer on the internet can actually do is it can either send a message to like another computer, it can say, all right, I want to send this message to the computer at IP address 128.0.0.4. Or it can receive a message that was sent to it. That's all that it can do. So what that means for how we browse the internet and go to websites is that how it works is like this. If we want to visit Facebook, then we type in the URL and our client, which is the web browser, sends a message to the server, which is some program running in a data set on a computer in a data center somewhere owned by Facebook. And it sends a request saying, I would like to see the Facebooks. And then the server sends back a response saying, okay, cool. And then it sends back all of the HTML, CSS, and JavaScript for the Facebook website. And then your web browser is happy. And then what your web browser's job is to take that HTML, CSS, and JavaScript and show you it in your computer. And the web browser is happy, but you are not because the red line is down. Okay, so just as a quick check of what I just said a minute ago, who sends the request? Give me one finger if it's the client, two if it's the server. Cool. Okay, yes, it is the client. So your web browser sends a request, and then who sends a response? Client, server. Yeah, server. Okay, amazing. So the client requests, or the client on this side of the slides, sends a request and the server do something, the server does it, and then it sends back a response. All of these are just packets, like information sent across the like underground wires that is the internet. So when we visit Facebook, we have this request and the response, but what that actually looks like is something a little bit more like this. This is the more formal structure of how requests and responses look on the internet. The protocol that defines exactly what these are supposed to look like is HTTP, which is Hypertext Transfer Protocol. Yes. All right. And another thing we can do is we can look at these requests that are being sent and received in our developer tools. So if we go to, if we're in our web browser, and then, oops, that's not control. Let's go to my, wait. I'm gonna find my security class course website. Cool. Okay, so what we can do is I'm gonna hit Command-Shift-I, but you can also do this. Oh, never mind. What's going on? Okay, this is not my computer. All right, I'm gonna right click and go to Inspect Element, and then we're gonna open up the Network tab. And the Network tab just shows us all of the requests going in and coming out. So if I refresh this page, we can see in the Network tab that there was a request here of type document. Okay, cool. Let's click on it and see what's going on here. The request URL was made to the URL of the website. It's a GET request saying, okay, give me information. This is the status code that we got back from the server. And then we also have all of this other information that HTTP sends back as part of the response. All of this information that HTTP had to send as part of the request. And then we can also look at what the response from the server was itself by going to the response tab. And oh, look, it's literally just HTML. So the server just sent back all of this, and then the browser rendered it, and it looks like my security class's course calendar. Actually, I'm not taking this class, but like in theory. Cool. Yay, we can see our website. So now we're done talking to the server, right? We can just like interact with the website on the client. Wrong. Let's look at an example. So let's say we have our Bank of America website, and we made a nice little request. Oops. We made a nice little request to get it. The Bank of America gave us back HTML, CSS, and JavaScript. We're showing it on our browser. Great. Now we're going to keep interacting with the website. So the basic idea here is that there's some code that Bank of America server gave us for our web browser to run. So now it's running just like on our web browser. There's also some code that Bank of America is just running on their server somewhere else on the internet. And they can choose whether they want to put certain logic either in the code that they keep running or the code that they give us to run. So where do you think we should put the logic to check if our username and password is valid? Do we want to put it on the code that's running inside of our web browser or in the code running on Bank of America server? 1 for our web browser, 2 for Bank of America server. Thoughts? Okay. Yes, I got 2 2s. That's great. Yeah, we do not want to be checking if our password is valid on the web browser because then some other evil person could just go to Bank of America, modify the code on their web browser a little bit, and then it lets them in. That would be sad. Where should we put the code to transfer money from one account to another? 1 for our web browser, 2 for the server. Yep, okay, exactly. We don't want that on our web browser. This is pretty obvious. We also do not want to be verifying a $1 million transaction in the code running in our web browser because we can just edit it however we want. We don't want to trust just anyone visiting this website. So bottom line is, as we keep interacting with the website, there are a lot of things that we're going to do where we need to still talk to the server that the website is sourced from. So we're going to show a couple examples of how we interact with the server. This is my 6031 course website from 3 semesters ago. And I want to do my reading. So I'm on the homepage, and then I click on the link to go to the first reading. So that's going to send a request, a GET request, to the 6031 website /reading1 to get that information. So then the server is going to be like, yeah, okay, we got it. They give back the HTML for the reading 1 page. Another thing I might want to do, inside O31, they have a little like the website. They have these little things where you click on there's a question, you click on the answer, you hit the submit button, and then it'll tell you if it's right or not. So for that, I'm going to attempt a multiple choice problem, and then we want to send that information to the server, see if it's right. So what we're going to do is send a different type of request. Before we sent a GET request to get HTML from the server, now we're going to send a POST request to send information to the server. So the information that we're going to send, we're going to send it to a slightly different URL, like reading1 /question1, like a specific URL just for the question. And then we're going to send in information as JSON, which stands for JavaScript Object Notation. It's basically just as a JavaScript object. We're just sending like key value queries. That's it. So we're going to send in my username maybe and like the answer that I guessed. And we have to send it as a post request because in a GET request, there's a lot less capability for sending information from the client to the server. And then, rather than saying you stupid, the server is going to give a more HTTP response that also has JavaScript object notation here, JSON, that will tell us certain information. Says it's not right, and then the web browser will update the page that I see accordingly. So that's the rundown of how these work. And I'm going to actually show you the 6031 website. So web.mit.edu/6102 something /spring 24. Amazing. So I'm going to open up the network tab here where I can see all of the requests going in and out. Then I'm going to go into reading 2. And so here, something that we see, here we go, is we made a request to get the reading 2 page. That's what I showed you earlier. So here we made a request, a GET request, and then we can see, yes, we can see the response that was our CSS. I think that's what this request was for. Okay, and then we can also see a bunch of other requests to get like images for the page and things. And now let's try a question. I'm gonna open this guy. I'm gonna guess the answer. Oh gosh, do I have to do all of these? All right, let's check. All right, let's find here. This says submit. That's probably our submit button. Let's look at what this request is. So you can tell the parts of the request here. The URL is a strange URL that we don't need to care that much about, that we submit our stuff to. It's a post request, like we said earlier. And then the payload is the information that was sent in the request from the client, from my web browser, to the OV1 server. And so you can see that I have an ID for like the reading that it's from, the category, all of this stuff, and then my choices. So that's like all of the things that I selected, and then a bunch more information that OV1 wants to receive. And then you can see here that this is the response that I got. It's also in the same format. It's just formatted a little bit differently here. And then here it shows that my answer was not correct. This was correct. This was correct. This was not correct. You know, all of this information. And then my browser renders it here according to whatever it received from the server here. Okay, any questions so far? Do y'all feel like you're following, generally speaking? Yeah, what's up?
So like, was that URL like the way you connected?
Yes, basically.
Like, is it like just a random? Like, what is that URL?
We will talk about that in a minute. So I'm going to ask you to hold that question and ask it again in a little bit. That is a good question. Okay, so basically we talked earlier about how we have our request, which has the URL that we're requesting, the method, which is like get or post. There's a few others too. Headers, which contains a bunch of information that's like stuff we don't really care that much about. And then the body of the request, which could contain like the information that we're sending to the server. And then we have the response, which has status code, which is like, was there an error or was it fine? Headers, also information we don't care about. And then the body, which could be our HTML for the website, or it could be information like we just saw for 031 that was just JSON to tell us whether we got the question right or not. So just a brief whirlwind of some status codes that you'll run into when you're programming. 404, which means that it couldn't find whatever you're looking for. Bad request, your request was somehow misformatted. 500 means the server did something wrong. 200 means you're good. So this is just a like breakdown of generally the direction that you should go in when you see a certain status code. generally, if you're programming and you are running something, you open up your network tab, you see a status code that's not to something something, that's not like good, then just take that status code, Google it, and look up what it means. All right, we just talked about the response. Okay, but you might ask, how do we know how our requests are supposed to be formatted? Like earlier, we had this example where I was sending information to the O31 course website, and let's say that, for the sake of our tiny example, that this was the format that the website liked, and then it gave us back whether the answer was right or not. Well, let's say I just wrote this instead. I just changed some of the words here and there. Then O31 would be very sad. It doesn't know what I mean. Oh no, so sad. So the basic idea that I'm getting at here, and it'll send back like a bad request or something like that. The basic idea that I'm getting at is that we cannot just like arbitrarily format our requests and send them to wherever we want. There has to be some kind of system for what kind of requests we're supposed to send and what kind of requests our server is expecting to receive so that it knows how to respond to them. So that brings us to APIs. So API stands for Application Program Interface. It's basically, we call it a set of endpoints that you can make requests to. And so there's two kinds of APIs that we'll be talking about. One is one that you make for your own website's backend. And then the other is an API that might be provided by like Google, Amazon, or OpenAI or something like that, that allows you to make requests to one of their servers and like take advantage of some of their services. So what does an API actually do? Let's talk more about that. Oh, yes. So our example, all right. The example that we're going to go to here is petstore.swagger.io. This is basically an API documentation. So basically the idea is that there is some kind of server, some computer running somewhere owned by this company called Swagger. That's the Swagger computer, running a program that's listening on the internet for requests. But it's saying, all right, if you are your client here, that's a really bad computer, whatever, then you can only send requests in these particular ways that are defined here. So for example, you could send a request to petstore.swagger.io/pet/ a certain ID /upload image, like a post request. And if you do, then in order for it to work the way you want, you need to send in these parameters. You could also send a GET request to /pet/findMyStatus, and you would have to send in these parameters. So basically an API just defines, like if you're going to send us a request, you send it to a specific URL. For example, like we'll have an endpoint for /pet, an endpoint for, what is there, /store/inventory or something like /store. And then we'll have an endpoint for /user or something. And then what this API is saying is you could send a request to /pet, and then we'll interpret it this way and send this kind of response back. So you'll define your own API for the server that you are running locally for your own app. But then this is also really popular for, especially for a hackathon setting, if you want to send requests to some other company. For example, you could send a request to the Open Weather API to get weather data to display on your website. You could get dogs, I don't know why you would, but you could get information about classes and people in classrooms at MIT. You could use the Twilio API to send text messages or emails, forward calls from your website. I don't know what the Twitter API does. You could use the Google Maps API to display a map on your website and like let the users edit it. Or you could use the OpenAI API to get GPT functionality within your website. So these are lots of different things. Generally speaking, if you are coding a lot for some kind of functionality, you should Google and see if there's an API for it, because there probably is. Note that a lot of these will require you to like get an API key or like rate limit or like pay or something. So just make note. All right, any questions so far about APIs, requests, HTTP, etc.? Are we chilling? Okay, cool. All right. Another thing worth mentioning is that there are certain tools that will allow you to send messages to a server, either your own or some other server, and that's good for testing your API. So you could try either of these. Cool. All right. So lastly, how do we make our own API? That's known as our backend. So in web development, we have the front end, that's the client, or like run on the client, sends requests to the backend gives responses. Normally in a web app, the backend sometimes has a lot of functionality like databases and things, but for the sake of our small websites, the backend is just going to be our API. Cool. So let's code it. Tony's going to show you guys how to use Flask.
Like, yay, backend. So now that we basically have a fully functional Netflix website for cats, let's go on to start making a backend for it. We see in our directory that we have a front end folder. Instead, now we want to create a backend folder. And in here, everything we're going to do, it depends on what framework we're using. For now, we're using Flask because it's the easiest one that there is. And we're going to create something called app.py. Now we want to set up the backend.
Okay, I don't know what just happened, but.
Janet.
Oh, I think he kicked you off the screen share. I think that's what happened.
Who kicked me out?
Yeah, stop.
How did I stop it?
Okay, you're good.
Okay. I'm going to go into the backend, and I'm going to create something called a virtual environment. So Python -m -v. The -m says that I'm doing something in Python -m. VNV means I'm creating a virtual environment. The other VNV means my virtual environment is called virtual environment. So it's a little bit repetitive. Yeah. The reason why we want to do this is because we want maybe later on in your classes or in your research or in your development, everything is going to have different package versions and you want everything to be streamlined. I'm on a Mac, so I'm going to do source VNV bin activate. I think for Windows, it's like VNV/script/activate without the source. So now I have my virtual environment activated. Now I can install all the packages that I want. So I want to install Flask and something called Flask cores. I think so many things. I think I want to import Flask. From Flask, import Flask. From Flask, import Flask. From Flask cores, import cores. Okay. And now I want to start defining my functions. Yeah. So as Abby said, there is usually a set of API routes that we have. So first I'm going to do the default one, which is just an empty bracket, which means that it's a default one. And here I can just define a function that returns anything. So this is saying when this API endpoint is hit, I'm going to return this. I'm also going to start my Flask app. Don't worry about what this code does for now. It's just a demo. So this is just a template for all the APIs that we can call. Now I can say something like Flask run, and it'll run this in a different port of our computer. So let's say I click on it. It returns something like hello world. So now this backend is running and it's prepared to answer to API requests. Specifically, when it sees the /nothing, it's going to return hello world. Now let's create a new route. But instead, we're going to specify it for movies. And what this API route is going to do is it's going to return a set of movies in the form of an array. And what is inside the array? Well, it's going to be exactly what we had earlier. Dictionaries that map the titles to the movie title and the year to the year. The rating to the rating. And let's just have two, just because why not? Now what we can see is if we have this website or this backend server running, and if we want to make a request to /API/movies, just kidding, I might need to reload this. It returns us the exact dictionary that we would want. So we had a question earlier on APIs. This URL tells us what exact information are we looking for. By default, usually it returns a big chunk of HTML compiled by React to serve you the websites that you interact with. And if we want certain types of data, we could specify that endpoint as well. Now we could go to our front end. And make that request to the backend. I'm going to use something called useEffects. And what useEffect does is for now, we're just going to say that it allows you to perform a certain action upon the first load of your website. You have to GitHub open. Did I send you? It's okay. Yeah, can you go to the front end?
Oh, that's it for fetch syntax?
Yeah.
Yeah. Where?
App, not TSX. Yeah. So I'm going to create a new function called fetch data. And what it's going to do is it's going to create a request, or yeah, it's going to create a request to my backend with the API specified at the movies endpoint. Now I'm going to unpack that data. And I'm going to set everything in the movies in the movie state to the response of that data. So let's see this side by side. First, what happens is that, oh, I have to call fetch data too. So first, what happens is that upon the first load of our web page, we call the fetch data function. That fetch data function makes a request to our backend at localhost 5000, specifically at the API movies endpoint. That movies endpoint sends us a dictionary mapping the string movies to a bunch of things that are movies, so titles and ratings. So once we get that back, we have the data, we set the movies in our state to be the value of movies here, which is the array of movies in Python. So if we go back to our React app,
Oh, you're just rerunning your server.
yeah, maybe we're running right now. Okay.
That was the NPM start.
Yeah.
Logo is defined, but
Go to fetch, go to fetch, go to fetch. Do I need to design this? Title,
Orange property, you mean?
yes. Oh, use effect is unique to React itself. It's saying that upon the first render of my website, do form this everything within this function. Yeah, more specifically, it says that if I have some type of state in this array, anytime something, one of these or one of the state in this array changes, I want everything within this function to run. But because there's nothing here, it's saying just whenever I reload the page on the first restart, then I get all of the data. Might be it actually. Oh, hey, it was that. Okay, so now our front end sent a request to the backend, and the backend responded to all our necessary movies in our API. Great catch.
cool. Is that it?
Yeah.
All right. I have a couple more slides and then we're done. Go back to the slides. All right. So I just want to break down a little bit of what you just saw, of what's going on in our computer. So here, each process binds to a certain port, which is a number on our computer. So we have our domain name, or in this case, our localhost, which is our IP address. And then we have colon, and then whatever specific like sub area of our computer it is, also known as the port. So if we're using our computer, if we're using our computer as a server, then we're going on localhost. And so this is localhost 3000 is where our front end runs. Localhost 5000 is where our back end runs. So basically we run two programs. The Flask run, which is our back end, it's a program running and it's going to be run on port 5000. And then port 3000 has a different program that's npm start, and that's on running our front end. So then we have our web browser. All of this is inside our computer. And so basically what our web browser does is it will send a request. If we go to localhost 3000, if we navigate to there, then we'll get our front end back, which will be the HTML, CSS, JavaScript, all of that we wrote in React. We'll get to see our website. Amazing. Now, if we also take our web browser and go to localhost 5000, then, or like localhost 5000 / whatever we want, whatever API endpoints are, then we'll be able to see the behavior of our API endpoints. So that will just like directly make requests to our backend. But the real magic is when our browser goes to localhost 3000, and then the React program that's now running in our browser makes requests to our backend. And then the backend and front end are talking, and like the front end will make a request to our backend to get some information. The backend will give it back, and then the front end will display it. So that's what Tony just showed in code of the React front end making the request to get the information from the movie's information from our backend that was running on a different program. All in our computer. It's a little bit of a mess, but it's good. All right, that was everything we had for our workshop. Any questions? Anything you want us to go over? Also to anyone who's still on Zoom. I don't think anyone's still on Zoom. Yeah. That's long. Huh? Yeah. All right. Cool stuff. Thank you guys for coming and for staying the whole time. The slides are in Discord. I'm guessing they'll post the video as well if you want to go back to anything. Yeah. Cool. Do I need to do anything? Do you guys need to make announcements or anything, or are we chilling? Okay. Oh, all right. We're hopping off Zoom then.
Thank you guys for staying.
Yeah.